Hello students, in this video we will find the position of center of mass of a uniform semicircular disc. Position of center of mass of a uniform semicircular disc. Okay. Now I suggest you to watch my last video where I found the position of center of mass of a uniform semicircular ring. And in case of a ring, semicircular ring, we obtain that the position of center of mass, if this is the ring, the position of center of mass lies on the symmetrical axis at a distance of 2r by pi. So this is for a semicircular ring. Now, to find the position of center of mass of a uniform semicircular disc, we have to use this data, that is the center of mass of a uniform semicircular ring. Let's see how. We can say that a disc is composed of many concentric rings of different radii. Suppose this is the disc. It has a total mass capital M and radius capital R. So this is R. Now I can say that this semicircular disc is composed of many rings like this. Now we will choose a very elemental ring at a distance, suppose smaller, at a distance smaller from the center O. Okay, proceeding to the next slide. Let's draw it clearly. This is the disc. Of radius capital R and mass M, and we choose a ring which has a radius of small r and a thickness of, suppose, dr. This thickness is dr. This is our elemental ring. This is the elemental ring, of course semicircular ring. Now we have to first find the area of this elemental ring, which I shading by blue color. You have to find the area of this blue portion. Now there are two ways to find this. The first way is an easy way, and the easy way says that if you just stretch this portion along a straight line, then what will be the length of this? This is a rectangle. The length of this will be pi into r, because this is half the circumference. And what is the thickness? Thickness is dr. Therefore I can say the area of this semicircular elemental ring is pi r into dr. There is another way. To find the area. It says that dA can be written as pi by 2 r plus dr whole square minus pi by 2 r square. Why by 2? Because this is semicircular disk, and we know the area of a semicircular disk is pi r square by 2. Now for what is this? This is the total area. Total area means this area. And what is this? This is this area only. So if I subtract the two areas, I can get the area of the blue portion. So let's analyze it. Pi by 2 common. This is r square plus 2r dr plus dr square minus r square. Now if I neglect this quantity, it is neglected because dr is very small, so dr square is also small. Therefore I will get pi by 2 into 2r dr, which is same as this, pi r dr. So you can use any method to find the area of the elemental semicircular ring. Now what will be the mass of that portion? Now for mass, I have already told that the mass of the entire semicircular disk is m and radius is r. Therefore by using unitary method you can say that mass of pi r square by 2 area is m. Therefore mass of unit area is m divided by this, so 2m by pi r square. This quantity is known as the areal mass density, which is mass per unit area. Now this is a constant quantity. Suppose I name it as rho. Okay, rho is the areal mass density. Okay, therefore the area of the elemental ring is what? Pi r dr. Therefore area mass of pi r dr area is dm. Therefore mass of the elemental semicircular ring will be dm equals to areal mass density into area of that ring, which is pi r into dr. So this is dm. Now suppose this is the disk, this is x-axis, this is y-axis, 0 0. This is the ring of radius r and thickness dr. Now if I ask you what will be the position of center of mass of this semicircular ring, as I mentioned in my last video, the center of mass of a semicircular ring lies on the symmetrical axis at a distance of 2r by pi. This is 2r by pi, at a distance 2r by pi from O, right or wrong? Therefore the coordinate of center of mass of this ring, of this semicircular ring, lies at 0, 2r by pi. I hope you understand. Therefore x coordinate is 0. Therefore I can say x com, you don't have to calculate it, because if x equals to 0, then x com is also 0, which is obvious. Now we have to calculate y of the center of mass. This is integration y dm divided by integration dm. Now what is y? Y is this 2r by pi. Putting the values, 2r by pi into dm. Dm is here rho into pi r dr divided by integration rho pi r dr. Now let's take out the constants. See here 2 rho is constant, integration r squared dr, and here pi rho is constant, integration r dr, rho cancels. Proceeding to the next slide, y com is 2 by pi integration, let's see, 2 by pi integration this r squared dr divided by integration r dr, right or wrong? Now let's come to the limit. The smallest possible ring has a radius of what, 0, and the maximum radius of the ring could be what, could be capital R. Therefore the limit is from 0 to capital R, that is radius of the disc. So 2 by pi, this will come as r cube by 3, and this is r square by 2. Therefore we will get what, 4r by 3 pi. Therefore the final answer is, for a semicircular disc, uniform of course, of radius r and mass m, the position of the center of mass is here, which has a coordinate of 0, 4r by 3 pi, 4r by 3 pi. Therefore I can say this is the symmetrical axis. Therefore center of mass of uniform semicircular disc lies on the symmetrical axis at a distance 4r by 3 pi from the center. Thank you for watching this video. In the next video I will solve a problem of AC Verma.